Hello geometry students. Here's your lesson for section 5-8, applying special right triangles. Missy McCarthy, Okemos High School math instructor. So in this particular lesson, we're going to justify and apply the properties of what we call a 45-45 90-degree triangle. That's one of our special right triangles. And the other special right triangle that we're going to justify and apply properties for is the 30-60 90-degree triangle. So if we take a square and we were to draw the diagonal of that square and call its length y. Now because it's a square, we have a right angle in the corner, and the diagonal will actually bisect the angle to give us 45-degree angle here, 45-degree angle here. The two legs of this triangle are both x because it's a square, and we don't know this side here, so the diagonal we're going to call y. So using the Pythagorean theorem, because we know it's a right triangle, we can do a squared plus b squared equals c squared. Now I'm going to substitute in what we have for the legs here. It's x squared plus x squared equals y squared, that's the hypotenuse, and this is 2x squared equals y squared. I'm going to use the symmetric property and write it the other way around. And then if we were to take the square root of both sides here, square root of this side, square root of this side, we end up with y is equal to, we can't do the square root of 2 because it is not a perfect square, but we can do the square root of x squared, so we get x times the square root of 2. So what we can say is that in any 45-45 90 triangle where the legs are x and x, the hypotenuse is always going to be x times the square root of 2, because that's what y is equal to. So we just substitute it right in there for y. So that's what this next theorem says. It's the 45-degree, 90-degree triangle theorem. And it says in a 45-45 90-degree triangle, both legs are congruent, so they called the legs L and L instead of X and X. They called them L for leg. And the hypotenuse is equal to the leg times the square root of 2. So the hypotenuse is equal to the leg times the square root of 2, which they've written there. So the two legs are L and L, and the hypotenuse is L square roots of 2. And that'll happen in every 45-45 90-degree triangle. Okay, so given that we have two 45 or a 45-45 90-degree triangle here, let's see if we can use that particular property or that theorem to find the missing side length. So because this is 45 and we know triangles add up to, the angles in a triangle add up to 180, this also has to be 45. Also, we can use the fact that it is an isosceles triangle. If the base angles are congruent, then the sides across from those are congruent. So that means this side length is also 8. So in a 45-45 90 triangle, the legs are equal. The legs are congruent. And the hypotenuse is equal to the leg times the square root of 2. That's what we had on the previous page. So if the legs of this triangle is 8 and 8, then the hypotenuse x has to be 8 square roots of 2. Now you could also do Pythagorean theorem here, and you could do 8 squared plus 8 squared equals x squared. This will be 64 plus 64 equals x squared. This will give us 128 equals x squared. Square root of both sides, and we get x equals the square root of 128. But then when you simplify the square root of 128, its largest perfect square is 64, and you will get 8 square roots of 2. So there you have it. Let's try it with this one. We know it's isosceles because we have x and x here. So by the isosceles triangle theorem, we know that this is 45 degrees and 45 degrees because this angle is 90 degrees. Okay, so given that, we know that x squared plus x squared is equal to 5 squared. This gives us 2x squared is equal to 25. Divide both sides by 2, and we get x squared is equal to 25 over 2. And then if we take the square root of both sides, we get x is equal to the square root of 25 over 2, which will be equal to the square root of 25 over the square root of 2, which is 5 over the square root of 2. And then we would need to rationalize the denominator. So we've got to think about what that means. Well, if we have 5 over the square root of 2, to rationalize the denominator, you multiply the top and the bottom by the denominator. So multiply the top by the square root of 2, multiply the bottom by the square root of 2. And then when you're all done, 5 times the square root of 2, your top would be 5 square root of 2. And then square root of 2 times the square root of 2 would be 2. So this would be your final length, and we've rationalized the denominator for a more appropriate or more simplified answer. Because, after all, it did say give your answer in simplest radical form. So we simplified it. Okay, now we're going to look at another right triangle, and this one, instead of starting with a square, we're going to start with an equilateral triangle. So our equilateral triangle is triangle PQR, where the side lengths are 2x, 2x, and 2x. X plus x is 2x. And what we're going to do is draw the altitude. Oops, my bad. What we're going to do is draw the altitude from here perpendicular to the opposite side, and we split this in half, so those are x and x. And then this altitude, the length of this altitude, we don't know what it is, so it's y. Now, because this was an equilateral triangle, these angles were 60, so when we split it in half, we get 30. So really, the triangle we're looking at is only half of this. We drew the altitude, which makes that 90. It was originally equilateral or equiangular, so that was 60, and when we split it in half, we got that to be 30. Now we know that this side length is x, one leg is x, and the hypotenuse is actually twice the side of that leg. It's 2x. We want to know what what the other leg is. So we can do a little Pythagorean theorem here, and we can say x squared plus y squared is equal to 2x, that whole thing squared. X squared plus y squared is equal to 4x squared. Subtract x squared from both sides, and we get y squared is equal to 3x squared. And then when we take the square root of both sides, we get y is equal to the square root of x squared is x, and then we have the square root of 3. So what this says is, in any 30, 60, 90 triangle, one leg is x. The hypotenuse is 2 times that leg, which is the shorter leg because it's across from the 30-degree angle. So the shortest leg is x, across from the 30-degree angle. The hypotenuse is always 2x, and we could write that right in there and say that the other leg is the shorter leg times the square root of 3. So let's see what that looks like in theorem form. So it says in a 30, 60, 90 triangle, we have these same conclusions we can draw. This right here is the shortest leg. The shortest leg, or across from the 30-degree angle, is always S, they're calling it, instead of X. I prefer that they use X because S sometimes can look like a 5, but I'm going to try to make it look as much like an S as possible. Here, this is the hypotenuse. The hypotenuse is always 2 times the shorter leg. And then here, we actually have the other leg, and as we just showed on the previous slide, the other leg is equal to the shorter leg times the square root of 3. So this is the longer leg. Okay, and you can see it in this diagram here as well. Again, the shortest leg across from the 30, the longer leg across from the 60, and the hypotenuse is 2s. So let's try a couple problems now utilizing what we just learned about 30, 60, 90 triangles. So here's a 30, 60, 90 triangle. Across from the 30 is the x, across from the 60 is y, and across from the 90 degree, the hypotenuse is 22. So we're going to use what we know, and I think I want to find the shortest leg first, because I know that the hypotenuse Actually, I think there's an easier way to write this. If we call this guy x, then we know that this guy is 2x, and we know that this one is x root 3. So now I'm going to solve the one that I can. We know that 22 is equal to 2x. So 2x is equal to 22. So that means x is equal to 11. So we've got the shortest side here. This guy is 11. And then the one across from the 60 has to be 11 root 3. So x is equal to 11 and y is equal to 11 square root of 3. And we have found x and y in that 30, 60, 90 triangle. And again, it says give your answer in simplest radical form, so I was sure to leave my answers as a radical. Here we have another 30, 60, 90 triangle. This time they didn't give us the hypotenuse. They didn't even give us the shortest side. The shortest side is x. The longer leg is x root 3, so that's x. This is equal to x times the square root of 3 is equal to this guy, and this guy is equal to 2x. X root 3, and 2x. So the equation that I have that I can solve is this one. I have x times the square root of 3 equals 15. I'm going to divide both sides by the square root of 3. That cancels, and we get x is equal to 15 over the square root of 3. I'm going to rationalize the denominator. So times the square root of 3 over the square root of 3. And that'll give us 15 square roots of 3 over 3. But this can be reduced. 15 divided by 3 is 5. So 5 square roots of 3. That's x. So x is equal to 5 square roots of 3. So we've got two sides. We've got the 15. We've got the 5 square roots of 3. And then this side is 2x. So y is equal to 2 times 5 square roots of 3, which is actually 10 square roots of 3. So we found y and we found x.